Welcome back to Java Internal's Crashcasts. I'm Sheila, and today we're continuing our journey through the Synchronization Utilities season. We're in the Synchronizers chapter, and we've just covered semaphores. Now we're moving on to a fascinating synchronization tool called CyclicBarrier. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to explore CyclicBarrier with our listeners. It's a powerful tool in Java's concurrency toolkit that can really help manage complex multi-threaded scenarios.
Great. Before we get into the details, let's start with a quiz question for our listeners. Imagine you're developing a multiplayer online game where players need to wait for a certain number of participants before starting a match. Which Java concurrency utility would be most suitable for synchronizing the start of the game when all players are ready?
That's an intriguing question, Sheila. It really makes you think about the nature of synchronization in a practical scenario. Our listeners will need to consider the requirements of the game startup process and match that with the capabilities of various synchronization tools we've discussed. I'm curious to see what they come up with.
Excellent. Let's give our listeners some time to ponder that while we delve into CyclicBarrier. Victor, could you start by explaining what a CyclicBarrier is and why it was created?
Certainly. A CyclicBarrier is a synchronization aid that allows a set of threads to wait for each other to reach a common point before proceeding. It was introduced in Java 5 to address scenarios where you need multiple threads to wait for each other at a specific point before continuing their execution. The cyclic in its name comes from the fact that it can be reused after the waiting threads are released.
That's interesting. So, it's like a meeting point for threads. Can you give us an analogy to help visualize this concept?
Great idea. Think of CyclicBarrier as a group of friends planning to meet at a specific location before going to a movie together. Each friend, thread, arrives at the meeting point, barrier, and waits until everyone else shows up. Once the last person arrives, they all proceed to the movie together. After the movie, they can use the same meeting point for their next outing, hence the cyclic nature.
That's a helpful analogy, thanks. Now, how does CyclicBarrier differ from CountDownLatch, which we discussed earlier?
Excellent question. While both CyclicBarrier and CountDownLatch are synchronization aids, they have some key differences. CountDownLatch is a one-time use object that allows one or more threads to wait until a set of operations in other threads completes. CyclicBarrier, on the other hand, allows a fixed number of threads to wait for each other to reach a common point and can be reused. Also, CyclicBarrier can execute a barrier action when the last thread arrives, which CountDownLatch doesn't support.
I see. So CyclicBarrier seems more suitable for scenarios where you need repeated synchronization. Could you walk us through the core methods of CyclicBarrier?
Absolutely. The main methods of CyclicBarrier are 1. Await. This is called by each thread when it reaches the barrier. It blocks until all threads have called await. 2. Reset. This allows you to reset the barrier to its initial state. 3. Get parties. Returns the number of threads required to trip the barrier. 4. Get number waiting. Returns the number of threads currently waiting at the barrier. The await method is the most commonly used. When a thread calls await, it's essentially saying, I'm ready and I'll wait here until everyone else is ready too.
That's really helpful, Victor. You mentioned earlier that CyclicBarrier can execute an action when the last thread arrives. Can you elaborate on that?
Certainly. This is called the barrier action, and it's a runnable that gets executed after the last thread arrives at the barrier but before any threads are released. This can be incredibly useful for summarizing results or updating shared state before the threads continue. You can provide this action in the CyclicBarrier's constructor.
Interesting. Are there any potential pitfalls or exceptions we need to be aware of when using CyclicBarrier?
Good point, Sheila. There are a few things to keep in mind. 1. Broken barrier exception. This can occur if a thread leaves the barrier prematurely due to interruption, failure, or timeout. 2. Interrupted exception. If a thread is interrupted while waiting at the barrier. 3. Timeout exception. If a wait timeout unit is used and the specified timeout elapses before the barrier is tripped. It's crucial to handle these exceptions properly to ensure your application remains robust.
Thank you, Victor. Now, let's talk about some real-world applications. Where might we see CyclicBarrier being used?
CyclicBarrier is particularly useful in scenarios involving phased computation, where you have multiple threads working on different parts of a problem and need to synchronize at various points. Some examples include 1. Parallel algorithm implementations, where different threads process different parts of data and need to synchronize between phases. 2. Gaming applications, as in our quiz question, where players need to be synchronized before starting a match. 3. Distributed systems, where multiple nodes need to reach a certain state before proceeding with a collective operation. In all these cases, CyclicBarrier helps ensure that all parts of the system are ready before moving forward.
Those are great examples, Victor. Before we wrap up, do you have any best practices or tips for using CyclicBarrier effectively?
Absolutely. Here are a few key points to remember. 1. Always ensure the number of threads using the barrier matches the party count you specified when creating it. 2. Handle exceptions properly to prevent your application from hanging. 3. Use the barrier action for any shared state updates to avoid race conditions. 4. Consider using a wait with a timeout to prevent indefinite waiting if a thread fails to reach the barrier. 5. Remember that reset doesn't affect currently waiting threads, so use it carefully. Following these practices will help you use CyclicBarrier more effectively and avoid common pitfalls.
Thank you, Victor, for those valuable insights. Now let's reveal the answer to our quiz question. The most suitable Java concurrency utility for synchronizing the start of a multiplayer game when all players are ready would indeed be CyclicBarrier. It allows all player threads to wait at a common point, the barrier, and proceed only when everyone is ready. Plus, it can be reused for multiple game rounds.
Excellent summary, Sheila. CyclicBarrier is perfect for this scenario because it ensures all players start simultaneously and can be reset for the next round.
To wrap up, let's quickly recap the main points we've covered about CyclicBarrier. 1. It's a synchronization aid that allows a set of threads to wait for each other at a common point. 2. It's reusable, unlike CountDownLatch. 3. Key methods include await, reset, get parties, and get number waiting. 4. It can execute a barrier action when the last thread arrives. 5. It's useful in scenarios like parallel algorithms, gaming, and distributed systems. 6. Proper exception handling is crucial when using CyclicBarrier. In our next episode, we'll be discussing another powerful synchronizer, Phaser. Stay tuned.
Great summary, Sheila. I'm looking forward to our discussion on Phaser. It's another interesting tool in Java's concurrency toolkit.
Thank you, Victor, and thank you to all our listeners for tuning in. If you've enjoyed this episode, please don't forget to subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth, accessible explanations of Java's internal workings. Until next time, happy coding!